FSharp, Functional First Programming on .NET. Agenda, Programming Paradigms, FSharp History, Why FSharp, Type Inference and Compilation. Getting started, Basic Workflow, Pattern Matching and Unions. Programming Paradigms. A programming paradigm shapes how you think about a problem as a sequence of steps that change state or as a series of transformations from input to output. If mutable state is scattered throughout a program, tracking down where and why a value changed becomes genuinely difficult. Almost every real-world code base blends paradigms, but the language's default style still shapes how naturally certain solutions come out. Any team working with concurrent or highly testable code benefits from a style that limits unexpected hidden state changes. Reasoning about a program built entirely from mutable variables and side effects doesn't scale cleanly as it grows. Imperative and functional programming. Imperative programming, C#'s default style, describes a program as a sequence of statements that change variables and object state over time. F# instead is functional first, treating computation as evaluating expression and composing functions, with immutability as the default. Imperative C#, mutable by default, statements change state. Functional first F#, immutable by default, expressions compose. Problems with imperative mutable code. Single point of failure, a shared mutable variable changed unexpectedly can introduce subtle, hard to trace bugs. Reasoning about a function's behavior requires tracking every place that might mutate its inputs. Concurrent code becomes far riskier when multiple threads can freely mutate the same shared state. Testing is harder when a function's output depends on hidden, mutable context instead of just its inputs. Refactoring imperative code safely often requires understanding a wide web of state changes. Misses out on the simpler reasoning that comes from functions that always return the same output for the same input. The F# language system source code is written in .fs files and compiled by the F# compiler into the same intermediate language (IL) that C# targets. Values are mutable by default, and mutation must be explicitly requested with the mutable keyword. Because F# compiles to standard .NET IL intermediate language, it interoperates freely with C# libraries and the wider .NET ecosystem. Other functional and functional first languages: Haskell, OCaml, Elixir. F# advantages: immutability by default eliminates a whole category of accidental state mutation bugs. Powerful type inference means far fewer explicit type annotations than many statically typed languages. Pattern matching and discriminated unions make illegal states genuinely hard to represent. The pipe operator makes chains of data transformations read cleanly left to right. Full interoperability with the .NET ecosystem means existing C# libraries are still usable. A concise syntax often expresses the same logic in noticeably fewer lines than an equivalent imperative version. A concise syntax often expresses the same logic in noticeably fewer lines than an equivalent imperative version. Everything is an expression, almost. One huge benefit is that in F Sharp, almost every construct, if else, match, even loops, is an expression that evaluates to a value. Because if else is an expression, assigning a variable based on a condition is naturally a single line, not several statements. Functions are themselves values, so they can be passed around, stored, and composed just like any other data. This expression-oriented design is what makes F-sharp code compose so naturally with the pipe operator. Thinking in expressions instead of statements is the single biggest mental shift when moving from C-sharp to F-sharp. Pattern matching and discriminated unions. Discriminated union, a type that can be exactly one of several named cases. Pattern matching branches on a value shape, exhaustively checked by the compiler. A discriminated union in action. The compiler warns if a match expression doesn't handle every possible case. The pipe operator. The pipe operator threads a value through a chain of functions left to right. History created by Don Syme at Microsoft Research with F-sharp first released in 2005. Drew heavily on OCaml, adopting its functional style to run natively on the .NET runtime. Became a first-class, fully supported .NET language alongside C Sharp and Visual Basic, starting with Visual Studio 2010. Open sourced and made cross-platform as part of .NET's broader open source shift in the mid-2010s. Continues to be developed by the F-sharp Software Foundation alongside Microsoft's ongoing involvement. Why F-sharp? Correctness, immutability, and exhaustive pattern matching catch entire classes of bugs early. Concise, expression-oriented syntax often needs far less code than an imperative equivalent. Type safe, strong type inference catches mistakes without heavy annotation overhead. Interoperable, runs on .NET, freely using existing C# libraries and tools. Great for data, a natural fit for data transformation, scripting, and analysis. Backed by Microsoft and an active open source community and foundation. F-sharp's type inference. F-sharp's compiler infers most types automatically based on how a value is used. Reading code top to bottom, the compiler works out each function's parameter and return types. Explicit type annotations are still allowed and often used for public API clarity. Never assume F-sharp's inference means the language is untyped. Every value still has a single, strict type, just rarely written out. F-sharp compilation lifecycle. Edit.fs file, write. Resolve types, infer types. F-sharp compiler, compile. Just in time on .NET. Git on .NET. Execute. Source is written. Its types inferred automatically. Compile to portable intermediate language IL. And finally, just in time, Git compiled and executed by the .NET runtime. Getting started with FSharp. This leads us to the three commands that get a project off the ground. .NET New Console, lang FSharp. Create a new FSharp console application. .NET FSI. Launch the FSharp interactive read, evaluate, print, loop, REPL to try code live. .NET Run. Build and run the application in one step. Basic workflow. Author, compile, execute, test, maintain, optimize. Composing, pattern matching, and testing. Some call compose, pattern match, and test. Sharp's everyday loop. Small functions piped together with vertical sign, greater than sign, often replace what would be many imperative steps. Exhaustive pattern matching means the compiler catches unhandled cases before code ever runs. .NET FSI lets you try a function interactively before committing it to a file. Immutable values make unit tests simpler since the function's output depends only on its inputs. Supports many workflows, data science, scripting, web backends, and general purpose application code. Work the same across every platform the .NET SDK supports. Any questions? Thank you.